Hi, welcome. To solve this integral calculus, which is an example of integration by parts problem, the formula to use is integral of u dv equals uv minus integral of v du. Now, we have to consider the order of u. What will be the value of u and the v in this formula? This can be deducted from Eilert acronyms in which algebraic function come before exponential function, and here this is an algebraic function and this is an exponential function. Then this will now be u will now be equals to x raised to power 2. Then the u will be equal to 2x dx, and the other one, which is the v, will be equal to e raised to power x dx. This will now be, by introducing integral to the both side, we have integral of the v equals integral of e raised to power x dx, and this will become v equals integral of e raised to power x, that is e raised to power x is the same thing. Now the next thing is to substitute this v, u, v, the v and the u into this formula. So this will now be integral of u, which is x raised to power 2, the v, which is e raised to power x dx. So this is our question, which is equal to u, our u is x raised to power 2, then v, which is e raised to power x, minus integral of v, which is e raised to power x, du is 2x dx, which is times 2x dx. Now this will be x plus c, and this will be x raised to power 2, x raised to power 2, e raised to power x, minus, this is constant, 2 integral of e raised to power x, x come first, and then e raised to power x dx, plus c. Now this is another integration by parts, so let's solve this first. So integral of x raised to power, integral of x e raised to power x dx. So for this one we use order of u and v, and for this one let's use s and t. So our formula for this one will be integral of s dt equal to st minus integral of t ds. Then our x here will be x equals x, then the s will be equal to the x, the t will be equal to e raised to power x dx, then t will be equal to e raised to power x. So by substituting this in here, we have integral of s, which is x, and the t, which is e raised to power x dx, equals our s here it is x, then our t is e raised to power x, minus integral of t, which is e raised to power x, the s is the x. So this will now be equals to x e raised to power x minus integral of e raised to power x dx, that is e raised to power x. So by substituting this in here, that will now be, our question is Our main question is integral of x raised to power 2 e raised to power s e raised to power x dx equals, from here we have x raised to power 2 e raised to power x minus integral of 2x e raised to power x dx plus c, and here x raised to power 2 e raised to power x minus, here we have solved this, so by substituting this into here, that will be 2 into here this one, that is x raised to power e raised to power x minus e raised to power x plus c, and this will become x raised to power 2 e raised to power x minus 2x, by open this bracket, 2x e raised to power x minus times minus, that is plus 2 e raised to power x plus c. Here we can factorize out e out of here, so that will be e raised to power x into x raised to power 2 minus 2x plus 2 plus c. So this is the solution of integral of x raised to power 2 e raised to power x dx. Thank you for watching.